Okay, hello, good morning. Today I would like to present two tools that I saw at the Semantics conference in Vienna, which I visited last week. I presented there Thermit on the Semantic Developers Workshop, and these two tools were presented there as well. So the first one is Clever. It's a Sparkle engine. It's not a triple star. It's just a Sparkle engine. So you load the data into Clever, and then you can query them. Uh, what's interesting about Clever is besides that it's not a triple star, that they boast quite nice performance results. It seems to be significantly faster than a lot of the existing triple store or Sparkle engines such as Virtuoso, GraphDB, um, Exastor, or I don't know which other triple stores. They claim that there's a couple of reasons. One of them is that it's written in C++. It has 6 indexes, which is not actually that uncommon. Most other triple stores use a similar combination of indexes as Clever. It also uses a vocabulary that maps IRIs or letters into internal numeric identifiers for faster lookup and comparison. What I think is unusual, at least I haven't seen it in other stores, is that the mapping into the vocabulary produces lexicographically ordered uh, identifiers, which means that if if one IRI is lexicographically before another IRI, its identifier will be also smaller than the other one, which is supposed to improve the retrieval of the values from the vocabulary, because they can say, okay, if the block starts on this number and the block ends on this number, and the number we are looking for is larger or smaller, we know that we can skip this block. Or the other way around, if the number fits within the block, they know that they just need to load that specific block and not the blocks before or after that. So that's supposed to be one of the major improvements for the performance. Other supposed improvements are that the development process is much more, let's say, industrial, or much more professional. It's not so much academic. So they claim that they have really professional developers who develop the tool in a way that commercial company would develop their product, which is supposed to also improve the code quality and thus also the performance and other important indicators. Clever is also, as usual nowadays, available as a Docker image. So you can, and also actually, which is quite nice, it's also a Python package. So we basically do just pip install Clever, and then they have a command line interface which you can use to manage Clever, and the Python script downloads the necessary Docker images and starts them and stops them as necessary. So this is quite nice. I was testing it yesterday. I ran into some of the problems are what you would expect, because it's not a triple store. It's not really usable for applications that create and update data regularly. So it's more like you have a bunch of data in RDF, you load it into Clever, and then you can run queries on it. But if you need to update the data frequently, this is probably not the best tool to work with that. Also, what I discovered is that it doesn't support named graphs. I tried exporting Termit data from GraphDB into nquads and then load it to Clever, and it just doesn't recognize the format. So only triples, which is kind of a bummer. Also, the command line interface is nice for the sample datasets that they provide, but if you want to use your own datasets, it's a little bit more complicated, and you can't really use it as it is. But for some initial testing, or some proof of concepts, it's quite nice. And also, it doesn't. I haven't found any way to enable or do any inference on the data. So it's basically just you have the data, and everything that you want to extract, any knowledge that you want to extract, you have to be able to write it into Sparkle. I will do a very quick demo of Clever. So this is the folder that I installed Clever into. There's a bunch of files because I already have the data loaded. So I have here this termit nt file. So it's a file of n triples. It's about 600,000 triples. In GraphDB, it was something like 1.3 million triples, because there's a lot of inferred statements. But the data set is 600,000 statements, which I loaded into Clever. And what it did is, or basically what it does is that it creates this Clever file where, or you can create it manually, but if you want to streamline it, you can use one of the existing sample Clever files for the sample data sets, and then just modify it as necessary. So I just created this file. What's most important is that these base URL and get data command, which is basically if you have the data somewhere online, maybe in a GitHub repository or some export in, I don't know, FTP or something like that, you here specify the command that Clever is supposed to use to get the data from the data source. And it is expected that the data will be downloaded into some files. And then you can say, okay, these are the files. This can be a pattern. It doesn't have to be just a file name. So it can be something like, all n triple files that you have in this folder. And then you say, okay, if I want to load the data or read the data, what kind of command am I supposed to use? And then these are the configuration parameters for Clever itself. So it will then, if you say Clever load, it will load the data. Okay, it's not maybe not. No, it's Clever index. Sorry, it's not Clever. It's not load. It's Clever index. But the result is that you get a bunch of these binary files containing the indexes, which Clever then uses when you query it. So now what I want to do is that I will start the Clever server, and I will also start the Clever UI, which looks something like, if we take a look at this link, it will forward us to this sample data, or there's actually a number of sample data sets that we can use. So this I will start locally on the data set that I have loaded. So this is the Clever UI. The problem is that if I do it like this, they have a command for that. It works very nicely. The problem is that it expects this Olympics sample data set, which I don't have. And again, the Clever UI has a configuration file, which is called Clever file UI YAML. It's a YAML file, obviously. And what I did was that I renamed the slug from Olympics, which was the sample data set, to Termit, which is the data set that I used to that I loaded the data into. And now the command doesn't work, which is unfortunate. However, what I can do is that I can use these, since I already have the Docker image with the Clever UI. I can just use these commands and start the UI manually. So this is what I will do. Okay, yeah, I have to remove the existing container, or I can actually start it again, right? Let's see what happens. Okay, I'm not sure if this is. Yeah, now it says Olympics, but the data are the termite one. So this is the problem, that there's a bunch of predefined samples, and it's not very easy to force it to show you your data set. But the data that I have here are our data, which you can see if I run this sample query that I created here. Now I am looking for terms which have occurrences in the first 50 characters in a file. So it's not a definitional occurrence, but a file occurrence. So just something that I was testing to make it work a little bit. So I get these results here. So it's not very, the data set is not large enough to see any like performance, to make any performance comparisons. I would say what they did was they had Wikidata export, which has billions of triples, and they show the performance comparison on that. But in my case, I was just trying to see if it actually works. So it does. That's the important part. So you can take a look at the index. So you can see that there is this 600,000 triples that I mentioned. So and the index is quite simple. And when you create a query, you can actually also look at the results of the query planner. So this is the query plan and the estimates of how long it will take and what the sizes of these individual parts are before they are joined. Of course, this query is very simple, so the query plan is also quite simple. But it's a nice touch. And actually, if the query takes a little bit longer, this is what I saw at the presentation that they had at the Semantics. You can see updating. You can see these values updating in real time. So if you like run the query and click analyze while the query is running, if the query is takes long enough, you can see the numbers being updated as the query engine is processing the query and creating the plan. So this is clever. I think it's quite a nice engine. I actually thought it was very new, but then I found out that the paper, which is also linked in the query UI, in the Clever UI, the paper is, or the original paper is from 2017, and in the paper they also stress support for text search. That they have some clever text index, so it's also supposed to be very, very good at searching in texts. But in our case, obviously, as long as we work with data that needs to be updated free, as well as queried, then Clever is probably not the ideal tool for us, and we will stick to triple stores like GraphDB or thje. Okay, this one you've seen. This I already showed. Okay, the second tool, or it's not just a tool, is Jelly, and Jelly is a binary RDF serialization format and also a streaming protocol. So its goal is to provide a good performance and good compression streaming, RDF streaming. So so the original idea was to use it for IoT with RDF, but I suppose they then pivoted to just also a general RDF serialization or binary RDF serialization. because there's actually, I don't think there is a standardized one uh, in general. Jena obviously has its own binary RDF serialization. RDF4J also has its own binary RDF serialization. But these are proprietary and it's not standardized in any way. So the Jelly protocol and the serialization format is it has an open source specification and it has a bunch of implementations. For Java, it has integration for Jena, RDF4J Titanium, which you might know as a JSON-LD library. They also have an implementation for Python and an experimental implementation for Rust. They boast some quite impressive numbers for in comparison to Jena serialization and RDF serialization. What I was testing it as well. It works nicely just to directly load RDF data and store it in a binary format, so that it's more compact and it's faster to load repeatedly or write as well. I also was able to get it to work as a serialization format for RDF4J. So I have an RDF4J server. I will show you in a minute, and an application serving as client for the server. And I used the RDF4J plugin that Jelly provides, and I added it to the RDF4J server, and then I used the RDF4J integration for Jelly on the client side, and I was able to get the RDF4J API to use Jelly as the data format for the communication between the client and the server. The performance difference was pretty much none, but I think the problem was that the amount of data that I was using for this test was quite small. I had some old SysL data that or not. It's actually not old SysL data. It was just some sample data, and I just said, okay, give me all reports, and it returned 1,700 statements. And the performance difference between the default, which for RDF4J is actually trig. I thought it was the binary serialization of RDF4J, but it's actually just trig. So it's text, and the performance difference between trig and Jelly was pretty much none. Obviously, I didn't run any sophisticated tests. I just created some sample application and timed it using system nanotime without any repeats or anything like that. But it, at least it is some indicator. I'm also not sure if we could use this RDF4J plugin with GraphDB. I think it should be possible because GraphDB does support plugins, and since it does support RDF4J API, I would expect the plugin to work with GraphDB as well. But I haven't tested it, and the question is whether it makes any sense, because maybe the communication client server, RDF4J client, and GraphDB or RDF4J server may not be the exact use case for Jelly. Maybe the benefits are not big enough to go through this customization process. But I don't know. Maybe we can do some more experiments and see if it makes sense. Anyway, I will show you a very quick, simple experiment that I did with Jelly. So what I did is that I took this. Well, actually, no, it wasn't. Yeah, I have this again, the termit data that I used for Clever as well. So this 600,000 statements, and I have them in nquads. I load them using standard RDF4J, and then I write them into the Jelly file. I load them again to see that it's readable as well. And I did the same also with the RDF4J binary format. And I will run this experiment. It's actually relatively quick, but there is a difference visible here. So you can see that just loading the triples from the mquads file takes about 5 seconds. Writing them into the jelly file takes a little bit over a second, and reading them again takes under a second. Doing the same, writing and loading in the RDF4J binary format takes a little bit longer, a little bit over a second to write and read, which is consistent with the performance numbers that they have also on their web page. So they say, okay, writing is slightly faster than the RDF4J binary format. Reading is much faster than the RDF4J binary format. And also another experiment I was mentioning was the RDF4J client. So here I have just a simple HTTP repository connected to RDF4J server, which I have locally. I am setting the preferred RDF format to jelly, and then I just open connection and read all statements that have the subject. Actually, the object is this IRI, which is basically give me all reports, all instances of report. So it returns 1700 statements in about 2 seconds. I will just comment this out so that it's a little bit faster. And I can run this experiment with the RDF4J server again, but without specifying the jelly format, which means that it will use the default RDF4J, which is trig. So it's 800 milliseconds. Now if I enable it again, yeah, it's very similar. There's not much of a difference. So as I said, very good for just plain loading and writing data. Maybe not as significant difference for using it in an application with RDF4J. And that's it. That's it for me. Here are some references. So this is the Clever website. All the sources for Clever are on GitHub. There also this is the performance comparison that they did. This is loading of the data, and here are some query results. And this is the web page for Jelly. Okay, thank you. That's all.
So maybe can I have a question?
Of course.
So this Clever, is it like does it have a normal Sparkle endpoint or?
Oh yeah. I'm pretty sure it does have a Sparkle endpoint because I think the UI is just we can probably just see it in the just. Oh, this is a WebSocket. No, this one will be probably. Yeah. You just
Okay.
call the endpoint and pass the query in the payload.
Yeah, I was thinking maybe if like we have some files, like I don't know, maybe we transform tables or we have some vocabularies, we can have these kind of clever individual clever like repositories and federate them using something maybe GraphDB or RD4J.
Oh, that's an interesting idea. Yeah, I actually think that I'm not. I think I read somewhere on the GitHub or something that they are working on support for federation within Clever as well.
Oh, okay, nice.
But I'm not sure if it's already implemented. But yeah, since it has a Sparkle endpoint, it can probably be used as a node in GraphDB or RDF4J Federation. Yeah, that's a good point.
And it doesn't support updates, right?
No, no, no.
No.
You have to reload the index.
Okay. Yeah.
Yeah, one thing that I didn't mention is that the clever index is supposed to, or it's much smaller, at least based on
Okay.
their
Nice.
measurements. So because otherwise, I mean, the queries that we do usually, or at least in my case, the performance difference probably is not large enough to validate.
Yeah.
Going through the installation and loading of data into Clever. But maybe, for some complex analytical queries, or if we have large enough data sets, it can make sense to try it instead of our usual setup with GraphDB. And the load time is, they say it's much faster. Yeah. So for example here,
Yeah.
you can see that these 400 million triples that they loaded 5 times faster than GraphDB or Virtuoso. Oh no, twice as fast as Virtuoso.
Hmm.
So, yep.
And about the jelly, uh, I probably didn't pay enough attention. Is it a binary? Yeah. Okay. It's a
Yeah,
binary.
it's binary. Yeah, yeah.
Okay. Is it compared with like zipped
Yeah,
arc?
it's it doesn't.
Yeah.
I mean, it does some compression, some base compression. So the data are compressed. But the guy who develops it, he's from Poland. He said that it's possible also to apply gzip over this
Oh, okay.
uh, to compress it even more. But then, of course, he said that there is also the performance penalty of going
Yep.
through the compression and decompression at the end. So yeah, if necessary, it can be gzipped as well on top of what it does by itself.
Okay. And last question to make this format work with RDF4J, like a
Mhm.
server that's like, let's
Yeah,
say, production. It's what's necessary to put the library there and
yeah.
some configuration maybe, or
That's interesting. I thought that what I needed to do was just put the jelly. They have an RDF4J plugin, uh, just a jar that you can download and put it into the RDF4J server. What I thought was that I can just put it into the Tomcats libs folder, and it will be picked up automatically. But that didn't work. What I needed to do was to put the jar file into the libs folder in the unpacked RDF4J server
oh,
directory.
okay.
So I had to go to web apps, RDF4J server, webinf, and lib. And here I put it here, and it works out of the box like this.
Yeah, that's I thought something like that, but you don't need to provide any
No,
configuration
no,
additional.
no, no, no. RDF4J is very nice in this because they use the Java Service Provider interface.
Okay.
So you just declare the service provider in meta-inf in your jar file, and then you can use it as a plugin. I'm just looking. Oh yeah, here it is. Yeah, Java RDF4J plugin.
Hmm.
Yeah, so it just works. You put it there, and it just works. And for the client side, they have Maven dependencies that you can just put the Maven dependencies, and then you integrate it with the RDF4J API. Either just saying, okay, here is the format that I want to use, and again through the service provider interface, it works. And if you are writing it, there's a bunch of configuration that you can use to optimize the writing or reading if you want to use it as with Rio.
Hmm. Okay.
This is copied from, or most of it is copied from their website. They have a sample application, so I use that. and just modified it to compare it to the base idea for G binary.
Okay, thanks. I'll maybe let somebody else ask if somebody has something to ask.